Today we're going to bring a little bit of factoring back from Unit 5 when we were factoring expressions. Instead, this time we're going to be factoring with equations, right? Applying these quadratics and able to find the solutions, the zeros, the x-intercepts, and the roots by factoring our equations. First, go ahead and take these set of notes before we get started. If you want to pause the video here so that you can take your notes, go ahead and pause the video. Now that you have the notes, you'll see that there's an example to the right-hand side, and it follows along with the steps, right? You set the quadratic equation equal to 0. If there's a y, make it 0, because we're basically saying what are the x-intercepts, which means the y-coordinate of the x-intercepts from that coordinate point, y is 0, right? It's a number comma 0, which is why we make it 0. We're then going to see from the equation, can we factor it, right? If we can factor it, once it's factored, right, for this example, it's x plus 5 times x minus 2. This is also called intercept form, which I will give you the formula in just a second. And this one didn't have a GCF, so we didn't have to take out a GCF. We will do some examples with GCFs. Then we set each binomial or each parenthesis equal to 0 so that we can solve for that specific x. And we find out that our roots or our x-intercepts are -5 and 2. Before, when I mentioned the intercept form, this is what I was talking about. Knowing this formula can help you identify, like, oh, it's an intercept form, right? It's not in standard form. It's not in vertex form. But instead, I can identify the intercepts immediately. Now, this one is also tricky, right? Because it's x minus p and x minus q. So those subtraction signs, be careful if you see like an x plus a number or x plus a number. If you want to find the AOS, you can find it immediately by adding up your x-intercepts and then dividing by 2. The A, as per usual in every quadratic equation, is still the same. It tells us which direction the parabola is opening up and if it has a maximum, if it has a minimum. So let's go ahead and do number 1. We're going to set this equal to 0. I notice there's no GCF, so I'm going to immediately factor it. Something times something will give me 1, and those two somethings will add up to give me 2, right? 8 times C sum B. Well, 8 times C, I'm trying to find factors of 1, which are just 1 and 1, and 1 plus 1 is 2. So my factored format, or my intercept form, is this. Now what I notice is that I don't have to split these up to be able to solve it because they're the same. Which means I'm just taking x plus 1, setting it equal to 0, and solving it. When I subtract 1, this is when I get a -1 equals x. A lot of you are going to say, oh, to factor, I'm going to get a 1, so my answer is 1. Be careful, it's not 1. It's actually -1, because what you're doing is you're solving for x, and originally you have x plus 1. Let's go ahead and try number 2. Number 2, same steps, go ahead and set it equal to 0, except I notice something. Although I cannot take out a GCF, I do notice that this is a difference of squares. Like I said, you're going to want to go back to your factoring rules, see what you remember about it. But difference of squares, essentially, it shows me that here's a perfect square, here's a perfect square, and there is no bx. It's missing, right? Bx is missing, which means b is 0. This is a rule where I know the perfect square here is 2x splits up here, and this is a -3 and a +3. So now I can split up these binomials. They are different from each other. And solve. So I get 2x equals 3 here, so x equals 3 over 2. I get 2x equals -3, so x equals -3 over 2. So this one ends up being a positive negative of the same numerical value. You can write -3 over 2, comma, +3 over 2. You can change to a decimal, keep it as a fraction. It's up to you, right? But this should be your final answer. Go ahead and try number 3 on your own. Pause the video here before you see the answer. For number 3, here are your answers, -3 and -1. You can pause the video here so you can take a look at your work. But let's move on. Let's go on to the next page. let's do an example where we do have a GCF, right? This one is already set to 0, so nothing for us to do there. But we do have to take out a GCF, and I notice that a 3x can go into both of these terms, right? It has to work for both. And so I'm left with an x plus 5. Sometimes you'll be able to factor what's in here. Right now, that is not the case. So I'm actually at this step where it's parentheses times parentheses. So yeah, I split it up. I go into 3x equals 0. Over here, I get x plus 5 equals 0, and I'm going to solve for my solutions. Here, when I divide by 3, I get 0. Over here, I get a negative 5. So my final answers are negative 5 and 0. What this means for later on is I'll just be able to plot the intercepts immediately. Go ahead and try number 8, and I'll display the answers. Go ahead and pause the video. Here's the answer to number 8. You'll notice that you could factor out an x, and then you split it up and are able to solve. We're almost done with this lesson. Most of what we will have practice are type 1 trinomials. I want to still try a type 2. Before we do a type 2, let's do one more GCF that looks a little different than what we did before. I can take out a 3 here. So what I'm left with is an x squared plus 3x minus 4 equals 0. This is different from before because now what I'm left with is I can actually factor from here, right? I have the option of dividing this whole thing by 3. I could have also done that over here, because what that does is get rid of that GCF, right? So it simplifies the equation. Basically, this is what it does. So I could divide, right, each term, and that's what I end up with. So then I can factor from here. I want to find factors of negative 4 that sum to positive 3. So I get an x plus 4 and an x minus 1, or an x minus 1 times x plus 4. I'm going to split it up so that I can solve for each individual root. So then over here I get an x equals negative 4, and over here I get an x equals 1. So a negative 4 and a 1 are our solutions. The part that you're going to want to practice more of are type 2 trinomials. This is when a is not 1, and there's nothing I can take out as a GCF. So if you remember, we do a times c, so x squared plus 3x minus 10 equals 0. So now we're finding factors that multiply to negative 10 but add up to 3. In this case, that is going to be x plus 5 and x minus 2. But if you remember with type 2 trinomials, we slip it over, but then we have to slide that a back in, right? We need to divide. This one cannot be simplified, so we're going to move it over. This one can be simplified, so it just becomes a 1. So I am left with 2x plus 5 and x minus 1. If you do not remember those rules, please go ahead and practice those, right? Take out your old packets, get some extra practice that might be uploaded online for you. Over here, I get 2x equals negative 5, so x equals negative 5 over 2, or a negative 2.5. And over here, x equals 1. So here are my two solutions. Again, it is up to you if you want to change it to a decimal, a fraction, or leave it as a simplified improper fraction. Go ahead and try number 8. As I leave this on the screen, you can pause it here and try number 8 before you see the answer. Here's the answer to number 8 on that page. I'm just going to scroll a little to get there. Except I have an error here. Pause the video and see if you can find the error. I forgot to slide my GCF back in. I need to make sure I divide by 3 so that when I split it up, it's not going to be this answer. Make sure that you don't make that mistake. It's why I wanted you to practice it, but let's fix my answers. So we're we're going to get an x plus 5, and over here, we're going to get a 3x minus 2 equals 0. All right, don't forget to slide it back. So now I have x equals negative 5. I get 3x equals 2. X equals 2 thirds. So I get a negative 5 comma 2 thirds. Oops, let me fix that brace there. So that is your final answer. Go ahead and continue to practice this. This is a tough concept, so there's more than enough practice in your packet.